Welcome back to topic 29, Rational Exponents. This is part 2, and we're going to jump into some examples. The first example is the cube root of 8. We want to simplify this. So, what we can first do here is, even though we don't see this entire example raised to an exponent, we know that if we don't see an exponent, it is automatically raised to the first power. So we can rewrite this example as 8 to the 1/3 power. And this again is using the rule that we determined in part 1, where a to the m divided by n is the same thing as the nth root of a all raised to the mth power. So this is just applying that rule to this example. So some of you guys might be able to determine the answer based off just your knowledge of multiplication, but what I like to do here is use something called the chocolate bar method. So we all love Hershey chocolate bars. Hershey's, will you please sponsor me? JK, but not really. So what I like to do here is, if we think about a chocolate bar, they're evenly divided up into sections. So, because I see that my denominator is 3, ooh, that rhymed, I'm going to have 3 sections. Now, instead of adding like you would normally do, I'm going to multiply all these sections together. And when I multiply all these sections together, I want my product to be 8. So I have to think, what number times itself again gives us 8? Well, I know that 2 times 2 is 4, and then 4 times 2 is 8. So in other words, 2 times 2 times 2 is 8. Now what I also like to do is, and the reason why I wrote it in this exponential form here, is look at the numerator of this fraction of the exponent. The numerator is 1, so that means of my evenly divided sections of my chocolate bar, I'm only going to select 1. I only want 1/3 of this chocolate bar, which is going to be 2. If I wanted, say, 2/3, then I would take 2 times 2, which would be 4. So now we can move on to the next example. The third root of 27, the cube root of 27. Well, we know that this is automatically raised to the first power because we don't see an exponent there. So we can rewrite this as 27 to the 1/3 power. Now, if we get our chocolate bar method, we get our chocolate bar. We have 3 sections. So I'm going to divide this into 1, 2, 3. And the product is going to be 27. So what number times itself again will give us 27? Now this again is where you really need to practice those basic multiplication skills, where they're really going to come in handy here. Well, I know that 3 times 3 is 9, and then 9 times 3 is 27. So 3 times 3 times 3 is 27. Now how many sections of this chocolate bar do we want? We just want 1. So I'm just going to take 1, and my answer is 3. Okay, moving on to the next example. This is the 5th root of 32. So again, this is all raised to the first power here. So this is the same thing as 32 to the 1/5. And instead of having a chocolate bar with 3 spaces, we're going to have it divided into 5 sections. So we'll get our chocolate bar, divide into 1, 2, 3, 4, 5. And the product is going to be 32. So when I multiply all these together, I should end up getting 32. Okay, well, I know that 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. How many sections do I want? I just want one section. So my answer is going to be 2. Now let's move on to the next example. Here, notice how I can't draw in a 1 as my exponent because I actually have a 2 in its place. So if I want to rewrite this as a fraction, or I should say an exponential form, we get 64 to the 2/3. So I'll draw my chocolate bar. So here, notice how I want 3 sections. So I'm going to divide this into 1, 2, 3. My product should be 64. So when I multiply everything, I should get 64. So we can think about this as, well, what number times itself again gets us 64? We can also think about this, rewriting this as 64 to the 1/3 power and then squared. So if we want to ignore this 2 right now, this exponent of 2, and just think about, okay, what would be 1/3, 64 to the 1/3 power? Well, we know that 4 times 4 is 16, and then 16 times 4 is 24. So we know we want 2, so I'm going to take 2 sections here. Now 4 times 4 gets me 16, so my answer is going to be 16. Now if I wanted to solve it using the other method, where we kind of break it out apart right here, I know 64 to the 1/3 power is just going to be 4. Then, though, I can square it, and 4 squared gets me 16. So that gets me the same answer. So however you would like to solve these problems, whether you'd like to do it with the chocolate bar method or kind of think, okay, well, this is really 64 to the 1/3 raised to the 2nd power. I know that 64 to the 1/3 is 4, and then I can square 4. That gets me 16. So whatever floats your boat, take your pick. Okay, let's go into the next problem. So here we have the square root of 8. Remember, whenever you don't see a number in that radical, in that little check mark house there, then it's automatically going to be 2. So we can rewrite this as 8. Remember, this is raised to the 1st power, so 8 to the 1/2 times 8 to the -5/2. And that gets us what? So remember when we were dealing with the multiplication properties of exponents, when we had the same base, what do we do with our exponents? We add them. So we will end up getting 8 to the 1/2 plus a -5/2. We're adding a negative here. So 1/2 minus 5/2, or 1/2 plus a -5/2, is 8 to the -4/2. Now what's -4 divided by 2? Can we simplify that exponent any further? We can. That gets us 8 to the -2. Well, this problem is dealing with a lot of properties here, so I love it. How do we deal with negative exponents? When we write our answers, we want to only deal with positive exponents. So here, this is really over 1. How can we change this so we don't deal with a negative exponent? We can take this entire quantity and put it to the denominator. So let's write this even further. I'm going to write this over here. So this is the same thing as 1 over 8 squared. Now what's 8 squared? What's 8 times 8? Well, that's the same thing as 64. So my answer here is 1/64. Now sometimes here we deal with variables. So don't get scared, that's totally okay. Now this problem, notice how it's already written in an exponential form. we have our exponent of 1/2. Please note that if you see this problem written differently, it might look like this. So we know, using our property of exponents, if we have everything raised to the 1/2, we can distribute that to every single factor of this entire product. So this is going to be the same thing as 81 to the 1/2 times m to the 6th to the 1/2. Now 81 to the 1/2. We can use a chocolate bar if you would like. That means a number times itself gets us 81, which we know is 9. We only want one of them. So 9 is going to be our coefficient. Now here, when we have a power raised to a power with our variable m, that means we need to multiply the exponents. So 6 times 1/2. This can really be 6/1, if that helps make it a little bit easier. Half of 6, or 6 times 1/2, is m to the 3rd. And that is your final answer. Okay, one more problem. Let's try, we got a negative exponent, yes. 64n to the 12th raised to the negative 1/6 power. So another way that we could have seen this be written would be the 6th root of 64n to the 12th, all raised to the negative 1st power. So this is another way that you could have seen this problem written that is equivalent to it. So what we can do here is, looking at this problem here, we can apply our exponent to every term. So we'll end up getting 64 to the negative 1/6 times n to the 12th to the negative 1/6. Okay, let's tackle this coefficient first. We know that if we see a negative exponent, that this is the same thing as 64 to the negative 1/6 over 1. And in order to get rid of this negative exponent, we can bring this entire quantity to the denominator to make it positive. So that will give us 1 over 64 to the 1/6 times, now here you could do the exact same thing where you bring it to the denominator, or we can just multiply with our n. So we'd have n to the 12th to the negative 1/6. So when we have a power raised to a power, we're going to multiply our exponents. 12 times negative 1/6 would give us n to the negative 2. So if we go back to our coefficient, we have 1 over 64 to the 1/6. So let's have our chocolate bar. This we want 6 sections. So 1, 2, 3, 4, 5, 6. And we want it to equal 64. And we're going to be multiplying. So what number times itself 6 times gets us 64? Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64, so it's 2. But notice here how we're dealing with the denominator. So my number is going to be in the denominator. So we're going to have 1 times n to the negative 2 over 2. Now again, with our variable, we see a negative exponent right here. So in order to change that, we're going to take that entire variable and move it to the denominator. So that will give us 1 over 2n squared. And that's our answer. Whew, see, not so bad. Okay, your homework is quizzes topic 29, which is online. And thank you so much for watching.